All right, 7.4, remainder and factor theorems. First thing we have to be able to do in this section is do synthetic division. And since we haven't done that in a while, let's practice that a little bit before we start. So if you remember correctly, you use synthetic division when you take a polynomial divided by a monomial. Okay, it has to be divided by a monomial, and we want to remember this is always supposed to be x minus a, so it's supposed to be a minus sign. This one has the minus sign, so a in this problem is equal to 3. And then this will be a polynomial. You want to watch for any time that it's in descending order and it misses an exponent. So this one doesn't. It goes 3, 2, 1, and no exponent. So that one is in order and it's not skipping any, so you don't need to put any zeros in the problem. So if you remember correctly, you set your box up and the A goes in the box. Now what we probably remember is we just used the opposite sign as before. Then we list our coefficients: 4, -9, -10, and -2. This first number just gets brought down, and under the last one is always your remainder. Now you multiply and add. 3 times 4 is 12. Add going down, get 3. 3 times 3 is 9. Add, -1. 3 times -1 is -3. Add, and get -5. So we know that this is called the depressed polynomial. So if this one started with x to the third and we've divided by an x, we know this goes down to 4x squared, and then write it in descending order. Plus 3x minus 1, and then we write our remainder as -5 over what we were dividing by, x minus 3. So this one has a remainder. What does that mean? So is x minus 3 a factor? Does it go in there evenly? No. So it's not a factor. Okay? Also, we should recognize that if x minus 3 is not a factor, then you would know that 3 is not a 0. So this graph does not cross the x-axis at 3. So it's what you can tell. So what we're going to do is actually try to find ones that do work, where you get a remainder of 0, then we'll know they are factors, so they are 0. So that's what we're going to use this for in the future. All right, another use for synthetic division is to do what we call these plug-in problems. So I'm going to do it the old way first, and then I'm going to just show you this new way, and then you'll be able to pick which one. So the old way, we would have said if we want to find f of 2, we're going to plug 2 into f of x for x. So put the 2 in. So you get 2 times 2 squared minus 3 times 2 plus 4. Now a lot of this we probably do on our head. So 2 times 4 is 8. -3 times 2 is -6 plus 4. 8 minus 6 is 2 plus 4 is 6. So then we talked about what does that mean. Well, you could say that y equals 6. Well, you know the point 2, 6 is on the graph. Okay, because f of 2 is really y. All those kinds of things. And so we've done that on the last quiz, so you should know how to do that. Well, this is just another way of doing it. Using synthetic division, you can plug numbers in as well. So if we're doing synthetic division, we need our box and then our coefficients, 2, -3, and 4. Bring the 2 down. Now what do we put in this box? If we're trying to find f of 2, we're actually going to put the 2 in the box. Don't change the sign. You only change the sign if you pull it out of a factor. So we're not going to change the sign this time. 2 times 2 is 4. Add and get 1. Multiply and add, and the remainder is 6. So you can see that the remainder is the answer. So it's just another way of doing the problem. Now for this simple problem, this old method is pretty easy, so I'm not sure that you would need to do the synthetic division, but consider the problem if I made this like 2x to the 15th and then all the way descending order. This synthetic division method might be faster. Or if I asked you to do like 10 different problems using the same f of x, then it might be faster to do synthetic division. But if you think about what did we really do here, we just checked to see if x minus 2 is a factor, or if 2 is a 0. And our answer to that would be no, because we get a remainder. So understand that what goes in this box is the 0. Okay, it's the 0. All right, moving on. Finding all the factors of polynomials. And that's what we're going to basically be doing for most of the rest of this chapter. So we have this problem down here. 2x cubed plus 3x squared minus 65x plus 84. And they're telling you that this is a factor. So that means it should go in there evenly. Okay? Now think about it. The factors of 84. What numbers go into 84? So what we want to think about here is this exponent's 3. So we're kind of thinking, well, we should probably get 3 factors then. Well, they're telling you one of them is x minus 4. Well, if you have to multiply these things all together and you need to get 2x cubed, doesn't one of these need to be 2x and then the other one need to be x? So that when you multiply them together, you'll get 2x cubed. And that's really your only choice. Now we would know that in these back spots, whatever we put in here, those 3 things have to equal 84. Well, I already know one of the numbers is 4 because they told me it was. So if we think about 84 divided by 4, that would be 21. So that would tell me these two have to multiply to get 21. Well, there's really only a couple choices. Probably a 7 and a 3, or it could be the other order, 3 and 7. It would make a difference because that 2x in there. So these are some of our choices. What you want to notice is since that's an 84, you're probably not going to put, a 17 in one of these spots because nothing multiplies together to get 17. So it gives you some ideas of what you're looking for. All right, so how do you do these? Well, we only know how to do x squared problems, and this is an x cubed problem. So you have to depress the polynomial down to an x squared, then you can either factor it or you could use the quadratic formula. Most of the time it will factor. So to get the depressed polynomial, you use synthetic division. So since they're telling you this is a factor, then you know that 4 is a 0. So it crosses the x-axis at 4. We know that much for sure. So let's depress this polynomial. We'll put 4 in the box. Then it's 2, 3, negative 65, 84. Bring the 2 down, multiply and get 8, add and get 11. Multiply and get 44, add and get negative 21. Multiply and get negative 84, and we should get 0 as a remainder. If you don't get 0 as a remainder, you did something wrong because they told you it should work. So what does that mean? That means that we know that x minus 4 times the depressed polynomial, 2x squared plus 11x minus 21 equals the original problem. So now we've got this down to an x squared problem. So we should either factor it or use the quadratic formula on it to get the zeros. Now the quadratic formula gives you zeros. It doesn't give you factors. And this problem said find the remaining factors. So I would suggest that it should factor. You would not want to use your quadratic formula. So we'll keep the x minus 4 and we'll try to split this one up. So I know it would be 2x and x. And then what makes 21? Well, 7 and 3 do. And we already talked about that up at the top, that we kind of knew that's what we were going to try to get. And so what's the right combination here? Well, let's just try it, and then you got to check. That would be 14 and 3. If it's positive 14 and negative 3, that would give me positive 11. So these are the factors. And if it just asks you to factor, you would stop. Okay? It may ask you for zeros. If it wants the zeros or the roots, you would look at these factors and say 4 is a 0, 3 halves is a 0, and -7 is a 0. But for right now, they just want the factors, so you don't have to do the 0 part. That's what we're eventually getting to. All right, one more practice problem. X to the 5th. So we're probably trying to find 5 factors. Now, you won't always get 5, but that's what we're trying to get. So they're telling you the first one is x plus 3. So we'll put -3 in the box because that's the 0. 16, 48. Now it goes 5, 4. It's missing 3. It's missing 2, 1, and none. So 5, 4, 3, 2, 1, none. So you got to make sure you put those zeros in. Bring the 16 down, and you know this should be a 0. If it's not, you've done something wrong. -3 times 16 is -48. 0, multiply and get 0, add, multiply, add, multiply, add, multiply. And we do get 0, so that's good. Now, we have x plus 3 times the depressed polynomial is 16x to the 4th minus 1. Well, that can be factored. That's a square minus a square. So we need to break that down. That's a no middle. So 4x squared minus 1 and 4x squared plus 1. But then we notice this is still a no middle. Now remember, a square minus a square factors, but a square plus a square does not. So we want to break down just that middle one to 2x plus 1, 2x minus 1, and this last one does not break down because it's got a plus sign. So those are all of the factors. Now notice, you only got 4 of them. It's okay because that one won't factor. If they ask you to find the zeros, you would get 5. This would give you -4. This one would give you -1/2. This one would give you +1/2. And then you would have to solve this one. So 4x squared equals -1. X squared equals -1/2, or 1/4, sorry. Getting ahead of myself. And now we have to square root both sides. So the zeros would be plus or minus I divided by 2, because you have to square root the -1 and get I, and square root the 4 and get 2. So now you have 1, 2, 3, 4, 5 zeros. So we have 4 factors, but we have 5 zeros. That's going to happen occasionally.